Hey, in this video I'm going to talk about how to work with positive and negative numbers. We're going to add and subtract them using a few different models here. We have the charge particle model as well as the number line model. Then we're going to move on to multiplying and dividing these signed numbers. And then we're going to go on to working with fractions and working with decimals. So to begin, let's talk about adding and subtracting these signed numbers here. So to begin, let's talk about this charged particle model. The charged particle model relies on the fact that if you have a positively charged particle and a negatively charged particle, they're going to have a canceling effect on each other. Okay, so this could be used in mathematics for some problems like this. If we have 5 plus a negative 3, for instance, this 5 could be represented with 5 positive charges because it's a positive number. Okay, so we draw 5 circles with the pluses in there. And then this negative 3 could be represented with 3 negatively charged particles. Now when we sum these together, when we add these two numbers together, we see that the positives and the negatives will have a canceling effect on each other. And what remains is going to be our solution. We have 2 positive charges remaining, so our answer to 5 plus negative 3 is a positive 2. Okay, now there doesn't need to be any canceling effect going on if the signs of these numbers happen to be the same. In that case, you would just count the total number of particles there were. But if there are any that are opposites, if you do have pluses and minuses, they will have a canceling effect. This could be used for subtraction as well as addition. So if we have 3 minus, now let's take 2 minus 7. Okay, if we have something like this here, we could change this to addition if we wanted to. Instead of subtracting a positive 7, this will be the same as adding a negative 7. So when we look at this problem like this, we could go back to the charged particle model and we could go ahead and do this. So the 2 is represented with 2 positive charges here, and the negative 7 is represented with 7 negatively charged particles. That's 5, 6, and 7. Now they're going to have a canceling effect. And what remains, these 5 negative charges, is going to be our answer. So we get negative 5 for the answer there. So that is the charged particle model. Now let's take a look at a few examples using the number line model. So with the number line model, this relies on the fact that the starting position plus the change in position will equal the final position. So what do I mean by that? Well, let's take a look at a simple example here. Let's take a look at 3 minus 4. Okay, so how can we think about this on a number line? Well, if we have our number line here, let me draw 0 and let me mark off some units. 1, 2, 3. Okay, and let's include some negatives here. We have negative 1, negative 2, and negative 3. Okay, and the tips of the number line tend towards infinity. So the right of 0, you go towards positive infinity. And when you're to the left of 0, you're going towards negative infinity. Okay, now the starting position here is 3. Okay, so let's mark off 3. Now we are subtracting 4. So if you subtract a number, you're going to want to be moving to the left. So we're going to move left 1, 2, 3, 4 units. And we get to negative 1. So using this number line model, we see that 3 minus 4 is negative 1. Or for example, if we have an addition problem like negative 3 plus 6. Okay, so again, we could use the fact that the starting position plus the change in position will equal the final position. So let me draw in 0. We have -1, -2, -3. Let me mark that. And then 1, 2, 3. Here's 3. Okay, so our starting position here is a -3. So we're right here. Now the change in position is a +6. So that means since it's a positive change, we're going to be moving to the right 6 spaces. There's 3, 4, 5, and 6. So we get here. Okay, so that means our final answer here, we ended up at the final position of 3. And that is the number line model for addition. And subtraction as well. So moving on. We have some general rules for addition and for subtraction. Now, these general rules, you'll have to recall what the absolute value of a number is. But let's take a look at the statement first. So if the numbers have the same sign, add their absolute values and keep the sign. If the numbers have opposite signs, you want to subtract their absolute values and take the sign of the number with the larger absolute value. Okay, so this could be a little confusing to think about, so it's best to try a few examples to do. But what is absolute value? First of all, the absolute value of a number is the distance from that number to 0, and it's to use absolute value, I have these 2 vertical bars surrounding a number. So for example, the absolute value of -3 is +3 because the distance from -3 to 0 is 3. Okay, and distance is a positive measure. So essentially what it does, it just takes the positive version of a number. Similarly, the absolute value of a positive number will just be that number itself. So in this case, absolute value of 3, you get 3. So now let's check this out. If the numbers have the same sign, add their absolute values and keep the sign. So if we have -3 plus -4, well, the absolute values are 3 and 4. You get 7, but it says to keep the sign, so that 7 should be negative. Next, if the numbers have opposite signs, you subtract their absolute values and take the sign of the number with the larger absolute value. So if we have 2 minus 8, well, the absolute value of 2 is 2. The absolute value, oh, this is addition, 2 plus -8. So the absolute value of -8 is a +8. Right, so we're going to take their difference. So we're going to say, okay, what's 2 minus 8? We get -6. And we also want to take the sign of the number with the larger absolute value. Okay, and the sign of this value here of 8 is negative, so that 6 should in fact be negative. So we get -6 here as well. Now the general rule for subtraction is to subtract 2 signed numbers, change the sign of the second number, and change the operation to addition. So this is what we did in the previous 2 models, in the number line and the charged particle model. And then you follow the rules for addition of the signed numbers. So like I wrote here, if I wrote 2 minus 8, this is saying, well, instead of writing 2 minus 8, let's change that to 2 plus a -8 to do that. And in this case, if we follow this rule here, we'll obtain -6. So those are the general rules of addition and subtraction. So let's move on to multiplying these signed numbers. So I have a few patterns written down here. We see 5 times 4 is 20, 4 times 4 is 16, and so forth. 3 times 4 is 12. Now notice that we're going down by 4s every time, right? So every time this number gets reduced by 1, our final answer is getting reduced by 4. Okay? So we get to 0 times 4 is 0. Now -1 times 4 if we go down by 4 again, we should get -4. So let's fill that in. -2 times 4, well, we should go down by 4 again and get -8. And then -3 times 4, well, we're going to get -12. Okay, so through this we could see that, positive numbers times positive numbers, we are getting positive numbers. Negative numbers times positive numbers, we're getting negative numbers. Okay, now let's take a look at the second pattern right here. Instead of multiplying by a positive number here, I'm multiplying everything by this -4. So from this first column, we know that 5 times -4 would be -20. 4 times -4 would be -16. 3 times -4 would be -12. And as you may notice, we're moving up by 4 every single step. So if we continue that pattern, every time we move down by 1 here, we're going up by 4 in our final answer. So if we move up by 4 from 0, we're at +4. So then -2 times -4, well, we should go up by 4 again to get 8. And -3 times -4, we'll go up by 4 again and get 12. So through this, we see that a positive times a positive should equal a positive number. A positive times a negative should equal a negative number. Or similarly, it doesn't matter in which order you multiply things, so a negative times a positive would also be a negative. And from here, we see that if you do a negative times a negative, we're going to get a negative. And these rules here are the same for division. Okay, so division is really multiplication in disguise as well. So as far as division is concerned, if you take a positive number and you divide it by another positive number, you'll get a positive. If you do positive divided by a negative, you're going to get a negative. Or a negative divided by a positive, we should still get a negative. And lastly, a negative divided by a negative, you'll get a positive. So these negatives seem to have a canceling effect on each other. Or if you do a negative times a negative, oh, did I say positive? I meant positive up here. I don't know what I said. All right, so negative times negative is a positive here. Down here, a negative divided by a negative is a positive. Okay, and the last rule you should look out for, anything times 0 here, you are going to get 0. So 0 times any number is equal to 0. As far as division is concerned, 0 divided by any number is going to be 0. Now, any number divided by 0, how about that? If the 0 is in the denominator, this is undefined. Okay, so we cannot divide by 0. All right, so that's multiplying and dividing signed numbers. Let's move on to working with fractions here. So let's talk about how we add and subtract fractions. So let's say we want to add 1/2 and 2/3. Okay, so when we want to add fractions, recall that what we need to do is we need to find something called a common denominator. So we want to find out what number 2 and 3 both go into. In this case, 2 and 3 both go into the number 6, right? 2 divides evenly into 6, and 3 also divides evenly into 6. So we want a 6 to be down here, and we want a 6 to be down here. Now, how do we get that? Well, for this 2, I'd have to multiply by a 3. Okay, now we can't just multiply this fraction by 3. We can't get away with that because that creates a different fraction. So to balance this, we multiply the numerator by 3 as well. Now over here in this fraction, in 2/3, we want a 6 in the denominator. So we want to put a 2 here. We want to multiply that 3 by 2. That will give us the 6, right? Now up in the numerator, we also need to multiply by 2 because that is what balances the fraction. Essentially, what we're doing is we're multiplying this 2/3 by the number 1. Okay, and that's a trick you use throughout mathematics. Multiplying by 1 in some form or another may help you solve a few problems. So for this one, if we want to add these fractions now, we go ahead and carry out the multiplication here. So this fraction will be 3/6 plus this fraction will be 4/6. Now that they have the same denominator, we could go ahead and add the numerators together. 3 plus 4, we get 7, and we keep that common denominator as 6. Okay. Now, the reason we need common denominators is because it's kind of like we're adding up these objects here. Like if we have 1/2 and then we have 2/3, the object half and the object third, these are different things. But in the case of here, when we have the denominator of 6, we're adding up 3/6 and 4/6. So these are the same thing, so we'll be able to add these together. Okay, so essentially what I'm saying, it's you could write it like this. You have 3/6, and then you have 4/6. So this and this are the same, right? We have 3 of these and 4 of the same thing, so we have 7 of these all together, which is equal to 7/6. Now the same goes for subtracting fractions. So let me put a little divide here. So if we want to subtract fractions, like if we have something like 4/3 minus, let's say 1/8, what we need to do is we need to find that common denominator. So 3 and 8, what number did these both go into? Well, they both go into 24. Right? So we want this to be a 24, and we want this number here to be a 24. So we want to go ahead and multiply this by 8 here. And we do the same for the numerator. Now in this fraction here, we multiply this 8 by a 3, and this numerator by a 3 as well to balance that fraction. So now this 8 times 4 becomes a 32, and this is divided by 8 times 3, which is 24. We have a minus sign. The 1 times 3 here becomes a 3, and the 8 times 3 down here is a 24. So now these have the same denominator, and you're able to subtract these. So we carry out the top portion, 32 minus 3, and we get 29. Now this is divided by our common denominator, which is 24. So that is adding and subtracting fractions. Now moving on to multiplying fractions. Now multiplying fractions is a lot easier. So if we have something like 3/4 times 1/2, for instance, to multiply fractions, all you need to do is multiply the top times the top and the bottom times the bottom. So 3 times 1 up top gives us 3, and a 4 times 2 on the bottom will give us an 8. So 3/4 times 1/2 is simply 3/8. Or if we have negative 5/7 times a negative 4/5. So first of all, recall that a negative times a negative is going to be a positive. So 5 times 4 up top will give us a 20. And a 7 times the 5 in the denominators will give us 35. And the fact that they're both negative and they're being multiplied together will tell us that this number here should be positive. So that's multiplying fractions. Luckily, that's not too difficult to do. Next up, dividing fractions. So dividing fractions, let's begin with a fraction divided by a fraction. So if we have something like 3/4 divided by 5/8. Okay, so how do we do this? Well, dividing by a fraction, it turns out, is the same thing as multiplying by the reciprocal of this fraction here. So, what does that mean? Now, this would be hard to do in your head to think about. Dividing is a little difficult. Multiplying is easy. So if we could turn this into a multiplication problem, it's going to be way easier. So instead of writing 3/4 divided by 5/8, we want to change this to a multiplication. So this is the same thing as 3/4 times the reciprocal of this 5/8. The reciprocal is the fraction just flipped upside down. So instead of 5/8, we're going to write 8/5. Okay? So this statement here is the same as this statement over here. Which one would you rather work with? Which one looks easier here? And I would definitely say this multiplication problem here looks way easier than this problem over here. So remember that if you ever have a division problem, you could turn it into a multiplication by flipping the denominator upside down, or taking the reciprocal of the denominator. So 3/4 times 8/5, well, that's easy to do. That's 3 times 8 up top is 24, and 4 times 5 on the bottom, we get 20. And if we wanted to reduce this, we see that 4 would go into 24, and it'll also go into 20. So we're going to get 6/5 for the final answer. Okay, so that's dividing by fractions. Last up, we have working with decimals. So when working with decimals, generally it would probably be best to use the calculator, but in some cases decimals could work out so that they may be easy to work with, but the decimal point may be throwing you off a bit. So let's take a look at something like 1.8 divided by 2. So how could we do something like this? Well, 1.8 divided by 2, the decimal point may be throwing you off just a little bit. What we do know is 18 divided by 2. Okay, that we'd get 9 in that case. So if the decimal point is throwing you off, move it to a place that makes it easier. So we're moving it to the right one, right? And instead we're going to do 18 divided by 2, which is equal to 9. Okay, but now since we moved it to the right one to make the problem easier for us, we're going to have to move that decimal place back to where it should be. So now the number 9, the decimal point is right here, but if we move it back one space, it's going to be here. So this answer is going to equal 0.9. Okay, or similarly, if we had 0.02 and we multiply this by 0.8, this is, it looks maybe like a difficult problem because of these decimal points here, but really, to make it easier, we could move this decimal point to the right 2 places to make this a 2, and then we can move this decimal point to the right 1 space to make this an 8. 2 times 8, we get 16. Now we just have to move the decimal point back how many spaces we moved it in the first place. So we ended up moving the decimal points 3 places to the right. So we're going to have to move it back 3 spaces to the left. Okay, so we had to move an extra space, so we need to add a 0. So our final answer here is going to be 0.016. So if the decimal points are throwing you off, you could move them to where you need to, just to make the problem easier temporarily, and then you can move that decimal point back however many spaces you moved it in the first place. So that is working with positive and negative numbers, and I'll see you in the next video.